This is IMAT 2021, question 26. So we're told that polydactyly is caused by a gene mutation, and we have a set of pedigree diagrams, and we need to work out which inheritance pattern can only occur when polydactyly is caused by an autosomal dominant allele and not by an autosomal recessive. So our first pedigree diagram looks like this. We have every individual being affected, whether it's male or female. Could this be autosomal dominant? Well, for that to occur, each affected person would need at least one dominant allele, and we can see that this could very much be the case. All of the offspring would just need to inherit one of the dominant alleles from their parents, and since they are all affected, they all have a dominant allele, therefore it could be autosomal dominant. But could it be autosomal recessive? Well, in this case, for them all to be affected, they'd all need to have the recessive, homozygous recessive genotype. And again, we can see that this inheritance pattern could work. All of the offspring would need to inherit one recessive allele from each parent, and because they have nothing but recessive alleles, that's always going to happen. So this could also be autosomal recessive, and therefore it's not the inheritance pattern we're looking for. Here is our second diagram. Could this be autosomal dominant? So before, if it's dominant, each of our affected individuals must have a dominant allele, and that also means that all of our unaffected people must be homozygous recessive, as they have no dominant allele and therefore are not affected. But what about our missing alleles? Could this inheritance patterns work? Well, let's see if we can fill them out. Because our parents all have at least one unaffected offspring, that must mean that all the parents must have a recessive allele. And we can see that this inheritance pattern would work. All of these offspring could inherit the associated alleles, therefore it could be autosomal dominant. But can it be recessive? Well, let's have a look. All of our affected individuals this time would have to be homozygous recessive. And there's something wrong here that we can immediately spot. It would be that this individual here would have to be homozygous recessive because its parents have no dominant allele. However, it's unaffected and therefore should not have our recessive genotype. So it cannot be autosomal recessive. Therefore, this must be the inheritance pattern we're looking for. It's only autosomal dominant, not autosomal recessive. Therefore, our answer overall is 2, giving us a final answer of E.